Hello and welcome to today's webinar, Leveraging Big Data Technology for Clinical Data Integration. Before we get started, I'd like to announce a few brief housekeeping details. Today's session is being recorded, and an online archive of today's event will be available a few days after the call. You will receive an email from AHIP that will ask if you would like to receive the archive. Please respond to the email if you would. I'd like to remind you of AHIP's antitrust statement and ask that you reference it in the Handouts tab. The antitrust statement prohibits us from discussing competitively sensitive information. Please keep in mind you may ask a question at any time during the presentation by typing your question into the chat box located in the lower left-hand corner of your screen and then click Send. You may adjust the size of the slides to fit your screen by clicking on the Scale button located in the upper right-hand side of your screen. We have with us today Shetang Patel, who is Senior Healthcare Consultant at CitiusTech with 15 years of experience spanning healthcare management and health policy making settings. His expertise includes business transformation, payer-provider integration and contracting, product design and implementation, core administration system evaluation and selection, business process reengineering, value-based insurance design, financial reporting, and consumer-centric operations. Prior to CitiusTech, Shetang worked for PwC Health Industries Advisory, serving payer and provider clients, Academy Health, and EP&P Consulting, health services research and policy making in Washington, D.C. Shetang holds a master's degree in health services administration from University of Michigan. Parang Somashwar leads the big data practice at CitiusTech, focusing on helping clients solve their data integration, management, and analytics problems using leading-edge technologies. He has strong expertise across clinical interoperability, HIEs, disease management, EMR systems, clinical imaging, payer system integration, and meaningful use compliance. He has over 20 years' experience in software development, systems management, and IT operations. Prior to CitiusTech, Parang was an engineering manager at QLC, where he managed several aspects of the company's product and services portfolio. Gentlemen, when you're ready, we'll get started.
Great. Thank you, Catherine, for that kind introduction. Thank you, everyone, again, for your time in joining us to discuss CDI and how to leverage big data technologies. Our objectives for this webinar today, before actually I get into objectives, I just want to make a comment, especially on the current political landscape and healthcare policy. Regardless of what happens, there are two things that we have learned will always stay constant in healthcare. Number one is a small percentage of the population will always be responsible for majority of the cost, whether it's 80-20 or 90-10, however you want to slice it. Number two is healthcare is always local, be it at the membership level, at the provider-physician level. One size does not fit all. So keeping this in mind, clinical data integration, or CDI, plays a significant role to better understand and manage your stakeholders and customers. With that, what we want to do is just define CDI from our perspective based on our experience, the value of it, what does it mean to payers' bottom line. Also talk about the overall capability maturity model within CDI. I would argue that of all the payers that are in our audience today, not two payers are exactly in the same place when it comes to executing CDI, realizing ROI. So we want to talk about that capability maturity model and explain that a little bit. And then we want to look at how can we understand an individual payer's capabilities, how do we evaluate their capabilities against CDI execution. And we'll come with a small framework that we'll talk about and discuss. And one of the key dimensions of that framework is going to be a technology dimension, which we'll expound on significantly for the second half of the presentation. And this is where we'll discuss big data technologies, what are the leading practices and suggested technology architecture that we have found to be very successful in our experience, and some real-world examples on how these big data technology components can be implemented to deliver value. So as you see, this is our agenda for today. I just went over kind of the order of the information that we'll discuss. So getting to CDI definition. So how do we define CDI? Clinical data is vast, to say the least, whether it's in the format, structure, and obviously in the information or the content that it carries. Our definition of CDI is integrating payer claims and administrative data with various clinical data sources beyond just the provider EHR to inform decision-making, to improve care, to reduce costs, and ultimately enhance patient engagement. And yes, we do use the term patient here on purpose because we are talking about personal clinical data. We truly believe that a given payer can not only make sense of it all, and yes, this graphic is meant to be confounding and overwhelming, but not only can a given payer make sense of it all, but create a total picture to serve its business needs. And the total picture essentially translates to the overall ROI that everyone seeks when integrating clinical data. But there's one key thing here. Imagine you were putting together a jigsaw puzzle with 500 other people. It would require a sound plan, a long-term vision, utmost commitment from top to bottom, and an astute coordination and communication across all those 500 individuals. And that is the way you can truly attain the ROI you desire. It's much easier said than done for various reasons. More than anything else, just as a function of time, things are disparate and fragmented in most organizations. But to truly achieve that ROI, you have to think of it from a coordination and communication perspective. Just some quick examples, right, in terms of what is the benefit that can be ultimately delivered. So if you think about some clinical data, let's take outcomes data, for example. Examples being vitals, diagnosis information, social and family history being pretty crucial here, active diagnosis or medications. What are some of the benefits that the payer can get from these? Forming that 360-degree patient longitudinal view to better manage care at the patient level or member level. Enhanced patient risk profiling to understand the potential risks for better population stratification. Increased operational efficiencies, example, reducing turnaround times required for pending claims or making medical necessity decisions. We're talking about some examples of operational data, such as scheduling events, referrals, discharge, or attestations. You can glean insights into outpatient care for effective readmission management. You can glean insights into referrals to manage network, to understand utilization patterns and network leakage, and ultimately, better provider performance management and collaboration with your providers. Timely data, again, the real-time component is critical here. Encounter scheduling, progress notes, PHR updates, other utilization metrics can give you real-time alerts, notifications for proactive interventions, whether this be in the form of utilization management or case management. Ability to influence where the patient goes or the member goes within my delivery system. This is crucial because you want to be able to get the right care at the right time at the right cost, the good old adage. The right cost is huge in terms of determining where the patient will get their delivery of care and the right delivery of care to, say, close a care gap. And finally, proactive utilization management. So those were some high-level examples that we talked about. But what does it mean for payers as far as their bottom line is concerned? Right, so based on our experience, we have kind of put those in three categories to quantify the bottom line. The first is revenue growth. Boost cross-sales is an example to identify additional emerging member requirements through clinical data, whether it's a newborn or a specific disease management program that you want to cross-sell to your membership. Improve revenue predictability by building a risk-adjusted portfolio that takes into consideration more granular risk scores because of the clinical data that you're consuming. Strengthen customer lifetime value by minimizing misfit plans, adverse drug events, and instances similar, missed benefit extensions. The second category that impacts the payer bottom line is cost efficiency. We can minimize administrative costs of claims servicing by automating pricing guidelines based on consistent clinical data. We can reduce operational costs arising from delays in resolution of claims or authorizations that are pending due to insufficient clinical information. We can limit fraudulent claims due to the inability to track members' movement across procedures and networks. Again, I want to control where my member goes within my network. You can address that very nicely through CDI. And the third category is impacting stakeholder behavior. We want to achieve rapid time to market on meaningful plans and care coordination efforts, especially when it comes to complex case management and wellness management. We want to redefine proficiency towards value delivery using evidence-based performance ratings, whether it's STARS, HEDIS, typical pay for performance, that impact physician behavior. We also want to improve population tagging and targeting, again, the ultimate goal of patient or member engagement, based on leading behavioral indicators that predict healthcare trends from member lifestyle choices. Now here, in this particular example, this requires kind of the new modernized sources of clinical data, right? Wearables, watches, phones. So again, something we'll talk about a little bit more from a technology standpoint as far as how we can ingest that information. So as I alluded to earlier, right, clinical data integration is not the same for everyone, simply because their capabilities are different. So what we have done is taken a stereotypical technology capability maturity model and used some of the business use cases from our experience as far as where they fit in that step-by-step maturity levels that we see across the industry, right? So starting from left to right, we go basically from least sophisticated from a data and technology perspective, specifically technology architecture and infrastructure perspective, on the right being the most sophisticated. So the first point is make sure you're able to utilize data that sits in-house, right? So claims data, pharmacy data, lab data. This can help you understand your HEDIS measures, improve your HEDIS scores if you use it proficiently and properly. It can also help with a lot of provider onboarding components in terms of what's missing and why do you need to engage the providers to get specific data in. The next level of maturity is how can you enhance an overall quality improvement program, developing composite quality measures, developing a single source of truth with all clinical data types, and then ultimately addressing care gaps and other aspects to improve your overall star ratings or KPIs. Now, this is where the traditional industry definition comes into play, which is integrating EMR or EHR of a given provider with a payer's care management platform. But the way we look at CDI is it goes way beyond that. So the next maturity aspect would be designing and executing alternate payment models, using predictive analytics to identify new bundles, not just what CMS prescribes in terms of bundled payments. Clinical outcomes data with episodes of care, optimizing risk adjustment, and ultimately improving member satisfaction through all these endeavors. But this again requires additional clinical data from disparate sources such as radiology, and we talked about the monitoring devices and mobile for additional clinical data sources. And finally, digitized management of care at a community level. In our opinion, this is the ultimate use of CDI. Remember, healthcare is local, so doing this at the community level can significantly improve your bottom line. This means focus on diseases and conditions by population or community segment. This means outcomes-based provider contracts, outcomes-based pharma PBM contracts, where there are a number of contracts with payers such as Harvard Program that have more than 10 contracts with PBMs that are strictly outcomes-based. Engage members to manage their own health and take ownership of their own health. And this does require additional external data sources, specifically community data sources such as registries, disease registries that are published that are by state or nationally. CMS, CDC, and CHS, they publish a number of different sources where you can understand the population at the locality level better to execute CDI. So it's not always easy to understand where your organization falls within this capability maturity gradient. You may have executed some use cases with great success. You may have failed in executing more complicated use cases. But it is important to evaluate what your capabilities are today and subsequently pick and choose the use cases for successful execution. So that brings us to the framework that we have developed to understand your current capabilities. And I apologize for the background noise, but apparently there's some construction going on next door. In our evaluation framework, you can determine CDI readiness against 4 dimensions: business processes, technology, organization and people component, and data. Now, data is both access and quality, usability of that data. The first one, organization, people. Again, these are components related to human resource readiness, team skills, and change management capabilities within a given organization. This also includes an aspect of commitment from the top to bottom. Business processes, having documented processes and handoffs across various departments, not only on the business side, but also IT and IT operations, with stringent controls and comprehensive KPIs. It's important when you develop these processes or when you document these processes to also develop KPIs that take into consideration all the various needs of different departments. Data, again, both access and quality. The breadth and depth of coverage of access to clinical data formats and standards is critical to understand what your capabilities are today. So I'll just give you an example. Right? In our model here, in our framework, we have 64 categories of data fields with hundreds of data elements for some of the use cases that we just talked about earlier that can benefit payers. And then ultimately technology. This is comprehensive technology infrastructure to ingest, process, store, and utilize clinical data. And this is where we'll do a little bit of a deep dive for the second 30 minutes to understand technology at a much deeper level, and specifically the big data technologies. So this next slide is basically just a very oversimplified example of how this framework works. In this example, what we have done is just given a random score, not a random, sorry, a score based on one of the clients we worked with. From an organization people perspective, they had a full score. They were well placed in terms of staff with skills necessary to leverage clinical data once it was made available through their IT infrastructure. And there was an organizational commitment on CDI strategy, execution, and value. The value piece, right, the ROI that we talked about a little bit earlier, it has to be constantly monitored. And again, that commitment is significant from the top to bottom. In business process, this particular organization had a lower score. There was a lack of coordination across departments, especially in IT operations, to utilize available clinical data from various providers. They had tons of data sitting in-house, but it wasn't usable on many levels. And a lot of this was due to lack of communication and coordination across different departments. Data. In this particular case, we were given it a full score because of a couple of different components. One is they had a comprehensive data model to integrate clinical data. Second was they had access to tons of clinical conditions, CCDAs, real-time alerts through HL7 messages such as ADTs, registries, as well as device data. On the technology front, they had somewhere near a medium score with average technology infrastructure, existing data lake, and EDW data models supporting storage for desired clinical data. But they had an ineffective use of MPI concept to aggregate the data. And again, ultimately what you want to do is form that member longitudinal record with all the history you can possibly gather on that member from a clinical perspective. Without the concepts such as an MPI, very difficult to attain, almost impossible to attain. So what the output was, right, in the scorecard, which is what you see on the left, the goal is to have a perfect diamond. And this is where the perfect diamond means that ROI that you want to realize. So based on your current readiness and score, there are certain use cases you can execute, while other more complicated use cases you cannot execute today. So when you think about CDI, you have to understand your current capabilities to understand what you can actually execute and how can you improve from a step-by-step basis. and move up that capability maturity model that we discussed earlier. Okay, the next thing we want to do is, so we talked about the 4 dimensions. We're going to take a deep dive into technology dimension and all the various components associated within that. And I'm going to hand it over to our Vice President of Engineering, Parag Someshwar, to do that.
Hey, thanks, Shitang. Can we move to the next slide, please? So let's now look at the technology infrastructure required to enable CDI. I'm sure parts of this would already be deployed at most provider organizations. In most cases, the existing infrastructure may need to be repurposed to support CDI. There may be some components, again, that would be new and would need to be separately deployed. So first and foremost is the IT infrastructure required to connect to provider partners. This includes VPN, secure tunnels, and setups like that. Public key infrastructure for secure key management is also important. This is required to ensure the integrity and security of transactions and of the data transferred. Authorization and access control mechanisms need to be in place to ensure reliability of parties involved in the data transfer. Again, this is probably something that most payer organizations already have in place because they're already working with partners in a variety of situations. Once the connectivity is set up, comes the requirement of setting up an ingestion gateway. Now, fortunately, this is largely a solved problem in the industry, at least on the provider side. There are a number of both commercial and open source integration engines that do a great job of accepting data using standard protocols such as HTTPS, MLLP, FTP, XDS, FHIR, etc., and then routing the received data to the right processing engine. Most interface engines are also highly configurable with respect to receiving data and to onboard routing. These can be leveraged easily for the purposes of CDI. We need to emphasize over here the need for a robust partner onboarding infrastructure. This will enable smooth onboarding of new provider partners, testing of the connectivity, testing of the messages, and then the go live, right? So the partner onboarding infrastructure also needs to be in place. Coming back to the processing engine now, the most interface engines allow for extraction of data elements from clinical messages. They support processing of data from standard clinical messages such as HL7V2, CCDA, XDS, DICOM, etc. Now, while these may be good to get started with CDI, for really extracting the wealth of data in clinical messages and then maintaining the relationships between the data elements correctly, you might actually need to write custom adapters, parsers, etc. By leveraging existing open source parsers. We'll talk more about this a little later. The processing engine is also where big data technologies can play a huge role. As you folks know, the volume of clinical data is exploding. The sources of data also are growing. Each clinical message is typically self-contained and has no dependencies on other messages. So the parallel processing that is afforded by big data platforms such as Hadoop makes them an ideal platform for processing clinical data. A lot of the clinical data processing work that we've done is on big data platforms, either on-premise, on Hadoop, or on the cloud, either on AWS or on Azure. Other than this, roster management and MPI being master patient index management, is also important for CDI. This is what will allow your provider partners to only send data for relevant patients to you. And again, as with all processing systems, operations management, dealing with transactions correctly, error management, dashboards for operational reporting, etc., also become important. We feel that in terms of storage, it is important that the raw message data with accompanying metadata is always stored. This is because very often messages need to get reprocessed, and it's always good to have a copy of the message handy. Again, big data technologies such as Hadoop, HDFS, or cloud storage such as Azure Blob or AWS S3 can be leveraged for this. It's also important to select a good data model as a reference for storing while storing clinical data. This becomes particularly important as different types of data, for example, medications, procedures, labs, conditions, and then later radiology, imaging, etc., need to be stored, processed, and correlated with each other. If a good data model is chosen, then it becomes easier to create a member longitudinal record, which really is the aim of CDI. Another thing to be taken care of is to ensure compatibility between the clinical data model chosen and the existing data models at the payer organization, such as that for claims, member management, etc. Shitan, can we move to the next slide, please? Right. So clinical data comes with its own reporting and analytics needs. One important need really is for reporting on data quality and profiling the data. We've seen that clinical data is generally messy in nature. After all, clinicians are more interested in providing care for patients than in recording the data correctly. So keeping an eagle eye on data quality is important. We'll talk a little bit more about this later. Data profiling is another thing that helps us understand the data better. This includes things like finding common data elements, detecting outliers, understanding the distribution of values over a range, and things like that, which help you to get a good measure of the data that you have. We have some customers, not too many, but some customers who have started performing streaming analytics, which means they look at data as it comes in and compare the data against existing data, come up with analytics output from that, which gets distributed out. This is something new. We have a case study on this that we will talk later in the presentation. Now, for most payer organizations, clinical data is not valuable in and of itself. It needs to be integrated with existing databases and applications. Hence, the CDI platform will need to expose APIs or endpoints for other applications to use. The mechanisms for the export of extracts also will be required. While doing this, reconciliation of data becomes important. This is a fairly challenging task, which we will talk of as we move ahead. We also listed some of the popular technology choices over here for data processing. In terms of integration engine, there are open source ones like Mirth, for example, or commercial ones like Cloverleaf, TIBCO interface engine. On the data processing side, Hadoop is a popular platform where there are different technologies available like Python, Apache Spark, Apache NiFi, and MapReduce. In terms of data store, as far as big data is concerned, we see a lot of activity where people are using Hive and HDFS. For downstream integration, typically standard ETL tools work quite well, but in some cases, we've also built custom big data programs using Python, Spark, etc. Data quality, data governance, there are standard tools available from IBM, Informatica, etc., which do a good job as far as managing the quality of data is concerned. Shitan, can you move on? A very high-level slide showing a very popular architecture for CDI, what we're seeing in the implementation. So step one is where your ingestion gateway comes in. This is where your interface engine will be. It will receive data from provider partners and route it with the required metadata to the data lake for processing. To the data lake over here. The data lake first acquires the data and stores it in its raw form. At scheduled intervals, the data stored in the lake is parsed. Different parsers are used based upon the type of data required to be processed. Required data is extracted, and the quality of data is checked. Exceptions are logged, and the extracted data elements are stored back in the data lake. this time in structured storage for later access. We've used structured storage like Parquet, for example, for access using Hive or Impala. The extracted data can now be queried using analytics tools such as Tableau, Qlik, or Power BI using standard SQL, or made available for extract using standard ETL tools like SSIS, Informatica, DataStage, or Talent. From the point of view of data quality, metadata management, metadata and operational data such as clinical codes supported by the payer, valid data ranges, etc. become very important. These can be loaded into the data lake for high-speed lookups. Real-time processing is also done in the data lake. Big data technologies like Hadoop have multiple ways of processing data in real time using technologies like Spark Streaming, Apache NiFi, or Apache Storm, which really allow you to look at data as it comes in and apply analytics on the data. So the data lake really is critical to CDI and acts really as a central element of the overall architecture. From the data lake, either raw or processed data can be exported to the research sandbox. This is typically accessed by data scientists. Depending on the regulatory requirements, the clinical data may be de-identified before being loaded into the research sandbox. So please note, in this schematic, the research sandbox is shown to be different from the data lake. This is not always the case. Very often, the research sandbox is hosted on the data lake itself, with merely the data being stored separately. We have seen both the cases in practice. For one of our customers, we were processing the data in the data lake and storing curated data into a massively parallel processing system on Hadoop called Hawk. The data scientists with the customers were using a machine learning library called MadLib to actually process the data on Hadoop. Another one of our customers is a Cloudera-based installation where we were loading curated data into Impala, which were being accessed by the data scientists for machine learning. At the other end of the spectrum was a customer for whom we were curating the data on Hadoop, but the customer used a tool from Alpine Labs, which would actually suck out all the data from Hadoop and apply machine learning algorithms out of Hadoop. So we've seen both these use cases as far as the research sandbox is concerned. Now, from the data lake, typically only the processed and curated data is loaded into existing data warehouses in the payer organizations. As far as EDW technology is concerned, we are seeing both symmetric multiprocessing and massively multiprocessing systems being used, depending upon the size of the data. Symmetric multiprocessing being your typical databases like SQL Server, DB2, or Oracle, and MPP databases being the kind of the real workhorses which allow for massive parallel processing. Databases like Microsoft's Parallel Data Warehouse or IBM's Netezza. As part of the ETL from the data lake to the EDW, typical challenges such as data reconciliation, normalization, and standardization need to be addressed. This can be really quite challenging for payer organizations because very often they don't have a deep understanding of clinical data and its complexities. So the ETL is something that you really need to pay a lot of attention to. In the clinical domain, the same element of clinical data can come from multiple sources. There can be clinical data already present in the data warehouse which needs to be reconciled against. Different sources may use varying code sets for the same entities, etc. So reconciliation, standardization, normalization, etc. of data before use becomes very important while doing CDI.
Yeah. So Parag, just a moment there. A comment. This concept of reconciliation, normalization, and standardization, right? It's absolutely critical. There are too many examples we have seen in our experience at clients where there is not enough discipline around this process, and it can lead to basically you're using the data incorrectly and or mapping it incorrectly, and ultimately the information that you want, right, which is those actionable insights, those are misleading. So the discipline around this process has to be very astute and paid attention to seriously.
Right. Now, the EDW data can be loaded into data marts for structured analytics. We have seen clinical data loaded both into its own data mart in some cases, or existing data marts can be enhanced with clinical data. We've seen this in the case of managed care data marts. Really a new trend that we are seeing, it's still quite new and we've seen only a few instances of it, but it's very interesting nevertheless, is of data virtualization. We are seeing customers use specialized tools from companies like IBM, Denodo, Cisco, SAP, and Informatica to carry out virtualization of data across various systems, including the data lake, to BI tools such as Cognos, ClickView, others. Right. So it gives really a unified view of data across the entire enterprise to BI tools. So this is something that we are starting to see now with our customers. Going up to data governance, MDM builds a central location of critical organizational data. It acts as a common point of reference for organizational applications. We see a lot of our peer customers generally do a good job with MDM. They manage various code systems well, member information, provider information, charge information, etc. Now, metadata management is something that is typically harder to get right. Now, as far as BI is concerned, we have seen a number of our customers use popular tools such as Cognos, Tableau, ClickView, Microsoft Power BI for canned reports and self-serve and ad hoc analytics. On the management side, we've seen our customers use tools like AppDynamics, Dynatrace, BMC, APM, and others for management of the entire data processing infrastructure. These tools allow provisioning and management. They provide a dashboard of system activity and also allow for issue detection, root cause analysis, and troubleshooting. So this was a very high-level walkthrough of the CDI processing architecture. In summary, a lot of the architecture for CDI is generally present within payer organizations and can be leveraged. Addition of a big data processing cluster as the data lake helps in economizing the cost of storage of raw data and for processing clinical messages at scale. Shitang, can we move ahead? Oh, sorry, I have control. Yeah, Shitang, I think we can skip the next 3 slides because they cover the reference architecture.
Okay. Yeah, and if it has a little bit more detail on these next 3 slides of all the different components Parag just went over. So if you have any questions or follow-ups on these specific aspects of the reference architecture, please get in touch with us and we'd be happy to talk through it. There is one comment I want to add around this last set of components, specifically business intelligence, number 8 here. There are a lot of different ways, obviously, that you can pull up these reports. But one thing we strongly recommend is when you think about your KPIs and reporting in general, that you think of a KPI hierarchy. So at the very bottom, right, when I think about clinical data and which KPIs it improves, like let's just take a HEDIS score, for instance, on a given measure. If that's at the very bottom of my hierarchy, you aggregate those HEDIS scores and get some information on a given provider or a provider group. You aggregate it at a level higher than that, and you get information across a given locality or given region. You aggregate it higher than that, ultimately, it gives you a corporate level understanding of that metric. So when you think about these KPIs, number one, look at all the different business departments across that are using that basic clinical data element or that can use that basic clinical data element. Look at the 4 dimensions that we talked about, specifically the process component, and then try to form KPIs that take all this information into account, and how can you aggregate it so that what you're viewing, whether it's your CEO or CIO viewing the KPIs at the corporate level, or you're a nurse manager, case manager viewing the KPI at the HEDIS measure level, it is all aligned. I think it's important to think of business intelligence in that form of KPI hierarchy to truly improve metrics and performance across the organization. Okay, I think next what we want to do is talk about some specific examples in our most current clients in the last 6 to 8 months and what the work we did there. So Parag, let me just introduce this particular case study and you can take over the solution. So this particular client is a single state blues plan where we did a CCDA processing in batch. It had a robust, or has actually, we're still doing some work there, robust infrastructure and processing capabilities with respect to claims and member data. What they wanted to do, the problem they were facing is wanting to integrate clinical data with member data to improve quality of care, specifically their HEDIS scores and ultimately star scores, and power digital initiatives across the enterprise. The solution that we utilized was to leverage a pre-built big data accelerator for data processing. It also helped understand data quality measurement and conduct data transformation. We worked closely with our business teams as well as the IT teams to deploy and also customize the solution. Actually, we ended up customizing it almost 50% to meet the needs of the client. And Parag, if you want to talk about the solution a little bit more in detail, please.
Sure. So in terms of the data sources for this customer, they were starting to receive CCDA documents for their members from EMRs. Athena Health, for example, was one EMR. And they were also receiving CCDAs from aggregators of health information. They were getting this based on the member roster, so they were only getting the CCDAs for those patients who are members, who are their members. The customer's IT team loaded the CCDA files into HDFS using FTP. So HDFS was used as a data store. What we did was we wrote a CCDA parser in Java, and around that parser we wrapped Apache Spark to enable parallelization. So that was used to extract the data from the CCDA files. The data was extracted in a very normalized format, and the format was almost similar to the structure of the CCDA document itself, which, if you've seen it, is a very information-dense document. For their business users, the customer wanted a certain set of queries to be enabled. Since querying on normalized data was not possible, we built a transformation component that basically we were able to configure on a case-by-case basis to transform the normalized data from the CCDA into a denormalized structure to enable the queries. The customer also had needs around understanding the quality of the data that came in according to along various dimensions. So, for example, whether the codes sent in the CCDA document were valid codes, were they codes that they supported, whether some critical data elements were null or not, whether dates were in a particular format or not, right? So they had a bunch of data quality rules. We built a small data quality engine for them, and we configured these rules using on the engine. The transformed data was stored on HDFS and made available for query through AHIP. Exceptions with regards to data quality, processing, etc., were stored in an audit repository on HDFS and were lit up on a dashboard using Tableau. And what we also did was, as we processed the CCDA files, we basically registered the information about the files into the customer's operational data store so that a business user would know for which of their members real data was available. So this was an overall solution that we built for them, and it is now live in production at this customer. Shashank, can we move ahead? Yeah, I think we can skip this slide, and this explains the previous slide. Have we missed a section on real-time CDI?
Looks that way. It's okay. We can just talk about this last piece. So the real-time CDI piece, I'll just briefly talk about it. It was with an HIE. This was in the past. But basically what they were looking for is how to ingest, not only how to ingest specific HL7 messages, ADTs in particular, but once you ingest them, how can you use them to send real-time notification to physicians? In their case, they only did it specifically to physicians. And Parag, I don't know if you want to talk about at a high level just kind of what the process was like, what was involved in that process to come up with that solution and also execute the solution. Any high-level comments?
Yes, sure. And sorry, folks, the slides are missing from this deck. We'll make sure that in the final version that is distributed, the slides are present. So for this customer, we again used a big data-based solution. The customer was receiving messages in the form of CCDA and HL7, ADT and ORE messages. We set up an ingestion pipeline using SOAP and HTTPS, which was basically feeding a Kafka queue. And from the Kafka queue, we set up a Storm topology that was reading from the queue. And we kind of embedded CCDA and HL7 parsers into the Storm topology, which parsed the data, extracted relevant information from it. In another bolt within Storm, we set up a rule engine. We leveraged JBoss rules for that. And the rule engine was configurable. You could set rules in it. You could set rules such as, let me know if one of my patients has got admitted into an ED. Let me know if the lab results for one of my patients is outside the safe norms. So there were providers who could register to receive such subscriptions, such notifications. So whenever a rule got fired, the relevant subscription would get triggered and the provider would get notified. This is again a system that we've deployed in production. It processes about 400,000 messages a day and sends out notifications based on what it finds within the messages.
Hey, Parag, sorry, there was a user error there. We do have the slides.
Okay, all right. Yeah, I think we can move on.
Okay.
Yeah, just next slide, Shashank. Again, right, we've been mentioning often about the fact that you would need to build your own parsers for processing clinical data if you want to do really deep extracts from the data, right, which is what you would need to do if you want to do CDI. Now, the clinical data typically is well structured, whether it's HL7B2, CCDA, imaging, radiology, or even claims for that matter, even though it's not clinical data. Also, newer standards such as FHI are also very structured data. For most of these types of data, there are open source parsers actually available using the common popular technologies such as Java, .NET, and Python. And these parsers are usually covered under the Apache license, and they can be leveraged for use without any encumbrance on your part. In most of the cases, it's also possible to wrap the open source parsers in big data technologies such as Spark, MapReduce, or Python. And this really is what enables parallelization. This is what we did for all of our customers. We took the open source parsers, we built a wrapper on top of that to extract the data that we need, and we further wrapped it around big data technologies to enable parallel processing. Now, when you do plan to leverage open source parsers, be sure to review the license for the parser to ensure that it's acceptable to your organization. We would advise that you do performance testing early to identify bottlenecks, if any, in the parser. And we ran into an interesting situation over here where, in one case, the underlying parser was not thread safe. And when we used it in Spark in a multi-threaded way on each node, we ran into problems. And then we had to kind of debug it and spend a fair amount of time trying to get to the bottom of it and, understood what was the cause of the problem and then fixed it. So the performance testing is very important. We also feel that enough thought should be given to data persistence, especially if persistence is going to be happening on Hadoop. Hadoop is structured differently from your regular databases. Hadoop typically doesn't do a good job with storing highly normalized data, and most of the data models are very dense, normalized structures. You might need to add a layer of denormalization to ensure that data can be stored efficiently and queried when required. So we also advise that enough thought should be given to how data is going to be persisted on Hadoop so that it can be accessed quickly. But it's really possible now with technology to build parsers on big data platforms so that the large amounts of clinical data coming in can be parsed quickly. Shashank, can you proceed? Shashank, next slide, please. Yeah, so we've been mentioning again and again during the presentation how important data quality is. It's important for you to pick a data quality framework that serves your needs. The data quality framework should be able to support different data models. It should be able to you should be able to configure and execute data quality and standardization rules. Ideally, the data quality framework should support plugins by which you can create your own custom rules. We've also listed some of the common types of data quality checks that need to be done. So you would need checks around missing data, null check, missing parent, etc. Checks around invalid data, data format checks, sequence checks, lookup code failures, range checks, and things like that. So these are some of the data quality categories that become important. Now, in terms of tooling, a lot of the ETL tools, Talent, DataStage, etc., have corresponding quality checking tools. So that is something that you could leverage. If you're doing it on big data platform, then you might need to write your own custom code using Scala or Java, or maybe even leverage IBM tools like Big Integrate or Talent, which run on Hadoop. So that's as far as data quality is concerned. Can we move ahead, Shashank? Data transformation again is important. As I was saying, the incoming data may be highly normalized. On Hadoop, when you store the data, it might need to be in a denormalized format. So you would need a transformation engine that could take the data and do a rule-based transformation from one side to the other. So picking a good transformation engine is important. Again, ETL tools typically do the job, but if you're doing it on Hadoop, then you might need to create a component of your own for doing this. Shashank, next slide. Data reconciliation, again, as we've been saying, is important when it comes to doing CDI. You could have the same clinical data coming in from multiple sources. Different clinical systems could be representing the same data in different ways, right? So it's important to have a good understanding of the clinical data from multiple sources. It's important to have a good end state for the clinical data, and then to be able to define rules by which data can move from each of the sources into your end state. So the reconciliation is extremely important. We have applied different strategies for reconciliation, including trumping, which kind of lets you set the priority between different sources for different data elements. We've updated entities based on records based on entity type. It's important to record errors in reconciliation so that you can look at it offline and fix manually. And then your data reconciliation mechanism has to scale as the data volume increases, right? So reconciliation is again something that you need to pay a lot of attention to while you're working on CDI. Shashank?
Sure. So that brings us to the end of our presentation, and I just want to revisit our objectives real quick. And we're open for questions that you may have. So while we wait for questions, again, we talked about what CDI means and how we define CDI and the impact, especially from a bottom line perspective, it has on payers. What the current state of clinical data integration, again, this is unique to each individual payer organization, based on their capabilities? How do you look at it? How to understand it? And also the framework to evaluate and understand that current state of capabilities, and how can you improve those capabilities and mature to ultimately get that golden ROI and that perfect diamond that you're seeking. And then we also talked quite a bit about leveraging big data technologies, and with the reference architecture and some real-world examples based on our experience. So at this time, Catherine, we'll take some questions in the last 5 minutes.
All right, thank you. As a reminder to ask questions, please, presentation, type your question in the chat box located in the lower left-hand corner of your screen, and then click Send. Now our first question is from Megan. What does MPI stand for?
Sure. That's the Master Patient Index, and for the most part it's MPI, and it's a general term in the industry. There's open source MPIs, eMPIs available, Enterprise Master Patient Index as they're called. And there's also other ones. Actually, I think I just read an article in Modern Healthcare the other day where Experian, one of those 3 creditors, they are building a unique identifier for the healthcare industry. Now, what they're doing is they're leveraging all their experience from the financial industry to build this unique identifier using probabilistic and referential matching. So again, a very crucial concept to form that member longitudinal record that everybody wants.
All right, our next question is from Vivian. What are the challenges that customers have faced in your experience?
That's not loaded at all. And Parag, please jump in. But any aspect in this presentation, right? Any slide, I can give you examples of some of the challenges that I've seen at client sites in my 15 years of experience. But one thing I will say, right? The number one challenge, right? If we could go back to that jigsaw puzzle, is how do 500 people put together that jigsaw puzzle? What is that coordination and communication required? What is that commitment required from the top down? What is that plan? From a business management consulting perspective, to me, that's the number one thing that is lacking, and people always miss on their ROIs and what the anticipated ROI is because those aspects are not clearly defined or executed from a coordination and communication perspective. A lot of payers have tons of, as Parag mentioned, most of the infrastructure is already in place. It's just a matter of aligning it and utilizing it in a manner that is effective. In our experience, that's the biggest challenge. Parag, anything to add there?
So when we've executed the projects, right, one of the things that we have found to be very beneficial is to work very closely with business to understand what they are looking really from the data, and giving them tools to empower them to actually access the data quickly, right? So that is something that we felt has worked very well for us when we worked with our customers. And whenever we had challenges, it's typically been because we didn't get the business perspective right. So working closely with business has helped us in a lot of situations to deliver a quality solution to the customer.
All right, thank you very much. That's all the questions we have at this time. So thank you both for that great presentation and for sharing your thoughts today. Thank you to the audience for participating in today's conference. That concludes this webinar. Thank you again, and enjoy the rest of your day.